Yo, what's up, y'all? We're going to evaluate the integral of e to the negative x cos x from 0 to infinity. It's going to be awesome. This is my favorite method. We're going to use Euler's formula. Bear with me. Yes, these are imaginary numbers, but trust me, this makes the integral a lot easier. It's pretty sweet. Normally, we evaluate this using integration by parts. I have a video on that. But by using this formula, it makes it a lot easier. Cos x is the real part of e to the ix. This is the imaginary part here. So by using this formula and subbing it in for cos x, we're going to evaluate the real part of e to the negative x, e to the ix. And this is pretty sweet because we can merge these together and add the exponents. And now we've created a super easy integral. So if we integrate this, we get the real part of e to the negative 1 plus ix divided by I minus 1 from 0 to infinity. We just now need to extract the real part out of this and evaluate it from 0 to infinity. So we're going to sub back Euler's formula and evaluate it. So this is it. So in the limit as x goes to infinity, this becomes 0. E to the negative 0 is 1, cos of 0 is 1, and sine of 0 is 0. So this whole thing becomes negative 1. So what this becomes is the real part of 1 divided by 1 minus I. And this is 1 minus I, and down here is I minus 1. The reason I swapped these in the denominator is because I have a negative 1 here. So I just brought this negative down into the denominator, so I didn't really have to worry about it too much. Okay, now we want the real part. Well, to get the real part of a complex number, we need to put that complex number in the form of a plus bi, where a is the real part and b is the imaginary part. Now we're dealing with a fraction, so to get it into this form, we need to get rid of the denominator, so we'll multiply the top and bottom by the conjugate. And knowing that I equals the square root of negative 1 and I squared equals negative 1, if we kind of expand this and simplify, you can pause the video to verify the fact, but we'll get 1 plus I divided by 2. We can split this fraction up into two fractions with a common denominator. And this, my friends, right here, this is our real part, which is the answer to our integral right there in all its glory. So the integral of e to the negative x cos x from 0 to infinity is 1/2, which is pretty awesome. What's even more awesome is that this imaginary part, this is the answer to the integral with sine of x instead of cos of x. Right on, y'all. You can check out all my other videos on integrals and other aspects of chemistry, physics, and math. Hang in there. I know integrals are not easy to learn, but you can survive. Cheers.